Welcome to ConcreteSection. In this video, we'll explore how the program performs design checks for reinforced concrete sections based on applied loads, factored results, and the interaction surface using the selected design specification. Let's get started. Interaction surface. After you define the geometry of the reinforced concrete section, the program automatically generates the interaction surface. This surface represents the section's strength for all combinations of axial force, Pn, and bending moments, Mnx and Mny. How this surface is calculated using strain compatibility, constitutive models, and equilibrium is covered in detail in the interaction surface and diagrams training video. Strength reduction and design specifications. Next, let's look at how the interaction surface is modified based on the selected design code. In the Project Manager Modify tab, you can choose from several supported design specifications, ACI 318, CSA A23.3, or Eurocode 2. Each of these applies its own set of strength reduction factors or partial safety factors in the case of Eurocode, and also limits the maximum axial compressive capacity according to that code. These factors reduce the size of the interaction surface, accounting for material variability, construction tolerances, and other uncertainties. For ACI and CSA, the maximum compressive strength depends on the transverse reinforcement type, either spiral or tied. For Eurocode, axial strength is limited by a minimum bending eccentricity based on the section depth. As shown in the image, enabling a design specification causes the interaction surface and diagrams to shrink. The black diagram represents the theoretical unreduced capacity of the section. The blue diagram, on the other hand, reflects the capacity with strength reduction factors and axial limits applied. If your factored loads lie inside the reduced interaction surface, like PU1 and MU1, your section is adequate. If they fall outside, like PU2 and MU2, the demand exceeds the capacity and the section does not meet design requirements. Next, let's look at an example of how to design a cross-section in ConcreteSection according to ACI 318. Applied loads and result cases. To begin a design check, we'll first need to apply loads on the section. These loads can include axial force and moments about the x-axis and y-axis. First, let's apply some dead loads to the cross-section. Next, let's apply some live loads. And finally, let's apply some wind loads. After applying these loads, let's open the Load Case Manager. This tool automatically generates result cases, which are factored combinations of loads based on the selected building code. These result cases represent realistic loading conditions that your section must withstand during its service life. You can view these combinations and their associated load factors right in the Load Case Manager. Once created, the software checks each result case against the strength of your section. Demand versus capacity. With the result case defined, ConcreteSection plots the factored loads as points on the interaction diagrams and surface. This helps you visualize the demands versus capacity of the section. As discussed previously, if the load point lies inside of the surface, the section has adequate strength. If it falls outside, the design fails under that load condition. These visual cues give you immediate insight into how your section performs under all load combinations. In the MX, MY, and Flexure tabs, you'll see how each factored result case plots relative to the interaction diagram. Keep in mind that these diagrams are simply slices through the interaction surface at the origin, and the demands shown are projected onto these slices. Note you can offset these slices by entering a value where you want the slice to be cut through the surface in the offset section of the project manager. You can also view the demands on the interaction surface and rotate the view to see which points fall inside of the surface or outside of the surface. Moment Unity Diagram. Now let's look at one of the most useful tools for assessing design performance, the Moment Unity Diagram. This view becomes available once loads are applied and the result cases are defined. The diagram shows horizontal slices through the interaction surface for each result case taken at the axial force level for that result case. You can switch between result cases to explore different slices, allowing you to instantly see whether the demands fall inside or outside of the interaction surface. For our example, we see that there are 2 points that fall outside of the interaction diagram, while the rest of the points fall inside of the interaction diagram. Note, if the applied axial force exceeds the axial link capacity, greater than phi p0 in compression or less than phi t0 in tension, the moment unity diagram for that result case cannot be generated. Moment unity value. In addition to the visual comparison of the demand and capacity, ConcreteSection calculates the moment unity value for each result case, which is the ratio of moment demand to moment capacity. As shown in the diagram, the moment demand is the distance from the center to the load point. Moment capacity is the distance from the center to the edge of the interaction surface along the same radial line. If the moment demand exceeds the capacity at the axial load level for that particular result case, the unity value will exceed 1 and the section fails. In the project status view, we see in red that moment unity is greater than 1, signaling failure. Clicking on this opens the moment unity report, where we can immediately see that the failing unity values correspond to the result cases that, as we remember, had points outside of the interaction surface. Unity values below 1 correspond to points inside of the surface. Since unity exceeds 1.0, we need to revise the design either by adding more or larger reinforcement, by increasing the size of the section, or both. Making these modifications expands the interaction surface. Now, all of the points fall within the surface, and all of the moment unity values are less than 1, meaning that the section passes. One final note. If no design specification is selected, unity values are based on the unfactored interaction surface. Be sure to select the appropriate design specification to ensure accurate results. That wraps up our walkthrough of design checks in ConcreteSection. You've seen how to apply loads, generate results, and evaluate section strength using the interaction surface and moment unity checks. For more guidance, take a look at the user's guide or explore our other training videos. Thanks for watching and have a great day.